Hey there and welcome. Today we're going to talk about something we see every single day but probably never give a second thought to: cement. It is literally the foundation of our modern world, but as we're about to see, this humble gray powder has a story that's way more complex and fascinating than you might think.
So let me just ask you a quick question. When you think of cement, do you just picture one standard, all-purpose bag of stuff? Because most of us do. But what if I told you that's kind of like thinking all cars are exactly the same?
Well, check this out. The source material we're digging into today doesn't just list one or two different kinds. It lays out over 10. That's right, more than 10 distinct and common varieties of cement.
And boom, here's the list. Just take a look. We've got the usual suspects, the different grades of Portland cement, but then you see these other wild-sounding names like hydrophobic or sulfite resisting. It becomes pretty clear pretty fast that we're not talking about one material. We're talking about a whole family of specialized tools, each one designed for a very specific job.
Okay, so let's start with the basics, the ones you've probably actually heard of. Ordinary Portland cement, or OPC. This stuff is the absolute workhorse of the construction world. But what's the deal with those numbers you see on the bags? 33, 43, and 53. What do they actually mean?
It's actually way simpler than it sounds. That grade number is just a direct measure of its strength. To be specific, it tells you the minimum compressive strength the concrete will have after it's been curing for 28 days. So it's pretty straightforward. The bigger the number, the stronger the concrete.
And believe me, this isn't just a number on a bag. This difference has huge, real-world implications. Your standard 33 grade is perfect for general stuff like plastering. Step it up to 43 grade, and now you're talking about beams and columns. But that 53 grade, that's the heavy hitter. The high-strength stuff you use for massive bridges, high-rise buildings, anything where you need maximum possible strength.
All right, so that covers the standard options. But let's be real. Construction isn't always happening in perfect conditions. What happens when you're up against extreme weather or you have really specific, tough requirements? Well, that's when you call in the specialists. This is where we get into the really cool problem-solving cements.
Okay, picture this. You're repairing a crazy busy highway, or maybe you're trying to build something in the dead of winter. You absolutely can't afford to wait the usual 28 days for the concrete to get strong. Time is money, and safety is critical.
And the solution for that is rapid hardening cement. This stuff achieves the same strength in just one day that normal cement takes 3 days to get to. That kind of speed is an absolute game changer for those fast-track projects or for building in the cold, where slow curing can cause all sorts of problems.
Okay, next challenge. Let's think bigger. Way bigger. Imagine you're building a massive dam or a super thick foundation for a skyscraper. When all that concrete cures at once, it generates a ton of heat. So much heat it can actually cause the whole structure to develop dangerous cracks from the inside out. Not good.
And that's where low-heat Portland cement comes to the rescue. It's basically engineered to chill out. It slows down the chemical reaction so the heat gets released much more gradually. This keeps the internal temperature under control and protects the integrity of these enormous structures.
Now, how about another hostile environment? Think about structures built right on the coast or in areas where the soil has a high mineral content. These buildings are under constant attack from chemicals called sulfates, which can literally eat away at the concrete over time, causing it to just crumble.
You guessed it, there's a cement for that. Sulfate-resisting cement is basically your shield. It's specially manufactured to fight off this chemical attack, making it the go-to choice for things like marine structures, sewer systems, or any foundation in sulfate-heavy soil. It's all about building something that's going to last.
All right, here's a super practical problem, one that can happen before a single drop of water is even added. What if you need to ship or just store bags of cement during a rainy season, or in a really humid place? See, moisture is cement's kryptonite. It can ruin the whole batch before you even get a chance to use it.
The solution here is pretty darn clever. It's called hydrophobic cement. During manufacturing, they add a special ingredient that basically coats each particle and makes it water repellent. This protective layer stops it from reacting with moisture in the air, so the cement stays fresh and ready to go even after being stored for a long time in damp places.
Okay, last category. Let's look at a more modern approach: blended cements. Think of these like alloys in metallurgy, where you combine ordinary Portland cement with other materials to give it new and improved properties, often making it more sustainable and more versatile.
A perfect example of this is Portland Pozzolana cement,
or PPC. The source material highlights two main kinds. One uses fly ash, which is a waste product from coal power plants, a brilliant way to upcycle industrial byproducts, right? The other type uses something called calcined clay. In both cases, these additives make the concrete easier to work with and even stronger in the long run.
Wow. Okay, so we've just gone through this incredible variety of cements. So what's the big takeaway here? What's the one single idea that ties all of this together and that you absolutely need to know?
It all boils down to this one simple but incredibly powerful sentence. This right here is the golden rule. It's not about which cement is the strongest or the absolute best. It's all about making sure the choice is driven by the specific needs of the job. To put it another way, there is no single best cement. There is only the right cement for the task in front of you. Using super high-strength 53 grade for a simple plaster job is just a waste of money. And trying to build a marine pier with a standard cement? Yeah, that's just asking for trouble down the road.
So this all leads to a really clear three-step playbook for success. First, you got to analyze the project and figure out exactly what it needs: speed, strength, a tough environment. Second, you match those needs to the perfect cement from this amazing toolbox we've just looked at. And finally, you always make sure the material you're using meets the established quality standards.
All right, so to wrap this all up, what are the key things to walk away with? First, stop thinking of cement as just one thing. It's a whole toolbox of specialized materials. Second, those grades, 33, 43, 53, that's just a simple code for strength. Third, all those special cements exist to solve very specific, very tough construction problems. And maybe most importantly, choosing the right one isn't just a suggestion. It is absolutely critical for the safety and the durability of anything you build.
Which kind of leaves us with one last big question. When you think about it, for almost every construction challenge you can imagine, whether it's speed, strength, heat, or even chemical attacks, we've engineered a specific cement solution.